So children, welcome back. Let us move to the worksheet number 4 of work power energy questions. Okay. So first question is here about a light and a heavy body have equal kinetic energy. Light body. That light body means lesser mass. Heavy body means larger mass. So light and heavy body have equal kinetic energy. Which one has greater momentum? Children, as we know that the formula for momentum P is equals to root over 2mk. Okay. P equals to root over 2mk. And as we know that 2 is constant and kinetic energy, equal kinetic energy they give. So kinetic energy is also constant. And we can conclude that this P is proportional to root m. P is proportional to root m, or P1 by P2 is equals to root over m1 by m2. P1 by P2 is equals to root over m1 by m2. But very clearly they have given that. What is the given condition? They gave that first body, lighter body. So mass of the first body is lesser than mass of the second body. So this implies root over mass of the first body is lesser than the root over mass of the second body. As P is proportional to root m, heavier the mass, heavier will be momentum, larger will be momentum. Lesser the mass, lesser will be momentum. So they are linearly dependent. So this implies that momentum of the first body is lesser than the momentum of the second body. So which one is having the greater momentum? Second body is having the greater momentum because it is heavy. And first one is having the smaller momentum because it is lighter. So lighter body has greater momentum. The heavier body has greater momentum. Both have same momentum. None of this. Which is the correct option, children? The heavier body has greater momentum. Larger the mass, larger will be momentum. Directly proportional. So moving to the second question. What will be the momentum of a body of mass 100 grams having kinetic energy of 20 joules? So what you are asked to find out is the momentum of a body. Mass is given and kinetic energy is given. So what is the relation between momentum and mass of a body, children? We know that momentum is equals to root over 2mk, where P is momentum, m is mass and k is kinetic energy. And given condition are mass is given as 100 grams. Though it is given in 100 grams, kinetic energy in joules and options are also in SI system. So, you have to convert mass in SI system. To convert grams in SI system, that is kgs, you have to divide this with 1000. Then you will get into kgs. So, mass is how much, children? 100 upon 1000 kg. Okay, or after further simplification, 0 gets cancelled, then it will be 1 by 10 kg. So this is the value of mass. And what else is given? The value of kinetic energy is given as kinetic energy. I wrote it as K is equals to 20 joules. Substituting all the values in the above equation, let us try to find the momentum. Therefore, the value of momentum P is equals to root over 2 times of mass is 1 by 10 and kinetic energy is 20 joules. So, simplifying, you will be getting this as root over 2 into 2 is root over 4 and this is equals to 2. Units of momentum is how much? What is, children? Kg meter per second. Unit of momentum in SI system is kg meter per second. So option number 1 must be true. That is 2 kg meter per second. Moving ahead with the next question, third one. Two bodies of masses 1 kg and 4 kg possess equal momentum. What is equal? Momentum is equal. Ratio of their kinetic energy is. So now we are asked to find out kinetic energy. So what is the value formula for kinetic energy, children? Kinetic energy Ke is equals to P square by 2m. This is what we have discussed. Kinetic energy Ke equals to P square by 2m. Now two bodies of masses, different masses. So mass is different, equal momentum, but momentum is constant. So we can conclude that the relation between kinetic energy and momentum is K inversely proportional to mass. K is inversely proportional to mass. So comparing their kinetic energies, comparing means first body kinetic energy to the second body kinetic energy. As they're inversely proportional, then they will be reciprocal, that is M2 upon M. K1 by K2 is equals to reciprocal of masses because they are inversely proportional. How much is the mass of the first body given? So given condition that first body mass M1 equals to 1 kg and second body mass M2 equals to 4 kg. So substituting the same values here, M2 replace it with 4 kg, M1 replace it with 1 kg. So K1 by K2 is found to be 4:1 or K1 is to K2 equals to 4:1. Therefore, the correct option is option 1, that is 4:1. Got it, children? So moving ahead with the next question, children. What is given? Two bodies of masses 1 kg and 4 kg having equal kinetic energies. What is equal? Kinetic energies are equal. Now you are asked to find the ratio of their momentum. So in order to find out this, you are asked to find the momentum. Formula for momentum is equals to root over 2mk. Momentum formula is root over 2mk, and what is given is masses. First body mass is 1 kg and second body mass is given to be 4 kg. Okay, and what else was given? Equal kinetic energy. In the given question, of course, 2 is constant and kinetic energy were also given to be constant. Hence, concluding we have P proportional to root m. Because 2 is constant and K is constant, we found that P proportional to root m. They are asked to find the ratios of the momentum. So, ratios of the momentum will be P upon 1. So, P1 upon P2, two bodies ratios. Then this will also be equals to M1 root over M1 upon M2. This is equals to, what is M1, children? 1 kg. And what is M2? 4 kg. So, P1 upon P2 is found to be root over 1 upon 4. Root over 1 is 1 and root over 4 is 2. Therefore, clearly we can conclude that the value of P1 is to P2 is found to be 1:2. And hence, the correct option is option 4, that is 1:2. Okay. So, moving ahead with the next question, fifth question. Two bodies A and B, two different bodies A and B of unequal masses. Masses are different. Having same momentum and same masses. Okay. Momentum is same. And have masses in the ratio 1:2. Unequal masses they said, and whose masses are in the ratio 1:2. Then their kinetic energies. You know, you are asked to find the ratio of kinetic energy. As we know the formula for kinetic energy, K equals to P square by 2m. So children, instead of K, I am simply writing it as K. So K equals to P square by 2m. Two bodies A and B unequal masses. So masses are different. Then what remains same? Same momentum. So momentum is constant and 2 is of course constant. So K is inversely proportional to mass. Larger the mass, lesser will be kinetic energy and vice versa. So taking the relation, we have K1 upon K2 is equals to reciprocal. No? So reciprocal means reciprocal of masses, that is M2 upon M1. Okay, larger the mass, lesser will be kinetic energy, reciprocal. So, what is M2, children? So given M1 by M2, ratios of the masses is given as 1/2. If M1 by M2 is 1/2, what is the value of M2 by M1, children? It must be reciprocal of them. If M1 by M2 is 1/2, M2 by M1 will be 2/1. So, this must be equals to 2/1. So, we found that the ratio of the kinetic energy is equals to 2:1, or directly we can write it as K1 is to K2 equals to 2 is to 1. So option 1 must be true, that is 2 is to 1.